Today I'm going to do a quick teardown and possible repair on this Hewlett-Packard 973A multimeter. Now this is a dual display multimeter, 3.5 digit with I think it's 4,000 count, 0.1% accurate. It's very tough actually. Oh yeah, that's not going anywhere. It's got the fluke style yellow rubber case around it, so they better not get sued. And let's see if we can get this thing off. Oh yeah, it came with some test leads. These are not cat rated, neither is the meter. They look fairly cheap and they're kind of crusty. I'll probably just throw them out. Oh, and this one's bent. Lovely. Anyway, I picked this up on eBay for 40 bucks and they said it's broken. I mean, it turns on. It does work. The screen is kind of crappy. Like, I see it a lot clearer on an angle than I do straight on. I don't know if that comes through on camera, but it's very faded looking dead on. And the main problem with it is he said that the shutter control for the amp range is broken, so we'll see if that's just like a quick fix. Maybe we could just rip out the shutter. I don't care. Get this off. Alright, we've got a little stand that doesn't click into place, but you know, very sturdy. And nicely they put what type of fuses it uses and what type of batteries it uses. It also has some information on the temperature readings. This thing can do as microamp and millivolt range. It can do thermocouple based temperature sensing, and it can do what is it, thermistor? Yeah, thermistor based ones. So let's see if we can open this up. What does it need? Oh, just a Phillips. Now there's a rubber seal around this thing. Not really sure what the deal is with that. But let's see if this... I can just yank it off by this thing, which probably isn't recommended. Aha! Alright, well, that wasn't too bad. There's some foil shielding on the back. Nice to see. And you can see there's a little contact spring to make contact with the back. It's got a teeny tiny fuse and one of the larger, the large 15 amp one. It's a dual board design with some lovely industrial alkaline batteries from Energizer. Ooh, I'll get those out of the way for now, since who knows what we'll be doing with the meter. And this board, not sure how we're going to get that out. It's got press fit posts on it, so I might have to somehow take out the whole board and then pop this off from the other side. The binding posts are nice screwed in type, soldered wires running to the board. You can see an old carbon film resistor. I'm not sure exactly what year this is. I know HP didn't make too many handheld multimeters, so it might be somewhat old. I'm going to take out these two screws at the top and see if I can get any further into this thing. Oh, and there's also a couple screws here. Alright, I think I got everything out. There were just some threaded screws, or self-tapping screws along here, and I took out the 3 or 4 screws holding the wires to the binding posts. And I think, yeah, there we go. There's lots of recess in this plastic. Very, very well made. That'll definitely keep you safe. The range switch feels kind of cheap. Maybe it's just been abused. I don't know the history of this multimeter. It feels spongy when you turn it. Like, even my Fluke 117B feels better. All the screws on the back are nice captive machined screws into nice brass fittings. And here we've got the display with a nice plastic shroud. There's a metal can over everything else with a big buzzer. And it's a second board here. See if I can get that off with some needle nose pliers. Oh, it's going through like a plastic shroud. It's going to be rather annoying to get off. Actually, let me just pop this off first. Oh, I need a smaller screwdriver. I just happened to spot this thing with the auction ending, and I picked it up. I didn't even know Hewlett-Packard made proper handheld meters, and this one's obviously a relatively high quality one. Yeah, even nice isolation slots on the board. It's conformally coated, surprisingly. You can see the gloss. There's none here under the dial, but they've conformally coated the whole board. I don't think I've ever seen that in a multimeter. Only the back though, or I guess that's the front. Sorry. Okay, I'm gonna see if I can pop these off. Okay, now we can see the guts of it. This is all sealed. This is the range switch. That's a very interesting design. I've never seen this before. What's happening is the range switch controls on the front are just moving this plastic piece, which in turn moves the mechanism all completely hidden. Like it's all reversed. I've never seen that before. Usually this is what's making the actual movement, and this is on the opposite side. Very unusual. I haven't seen that before. Got huge, nice one of these, really fancy trimmed resistors or whatnot. Not like the Fluke hybrids, because this looks like it's just one. It's just got two connections. It's just a resistor. But Fluke will use these fancy multi-tap resistors for all their ranges and stuff. There's a nice little shroud over the fuse, the little one for the, what is it, the milliamp range? Yeah, microamp. Oh, it's actually an HRC fuse as well, and even, aw, so cute. And we've got decent wiring going to all the terminals. Nice cutouts for high voltage clearance. What are these? P1, P2, are these poly fuses? I'm not sure. A few trimmers, whole bunch of trimmers. And a secondary board. Looks like just like op amps. Not much else. I figured the second board would be the True RMS or something, but generally True RMS is done in a big chip, so I'm assuming the main chip is doing that. It's covered up with a marker. Kind of annoying. It's probably just a standard multimeter control chip. They all pretty much use the same stuff. There's a big MILF style. Is that, it's X2? Is that a clock crystal? That's, oh yeah, and there's even the two capacitors. Wow, I've never seen a MILF style crystal before. It's right next to probably a 32 kilohertz clock crystal. It's a pretty good design. I mean, it's dated. Obviously, there's a lot of manual adjustment in this thing, and just the component design. Some of them are older styles. There's a big Zener diode there, a big glass enclosure. That's pretty cool. Oh, and there's a thermistor. That's probably the reference for the thermometer when you have it in temperature sensing mode. Well, I'm going to move on to the case and see what we can do about this slider. So, the slider mechanism is behind these screws. It looks like I mean, it still works. It just pops out at the bottom. Is that normal? Is that a safety thing to keep you from doing it? Oh well, let's take it apart, see what happens. Self-tappers into plastic. Does this come out? No. This thing's actually remarkably clean inside, so it's probably been used in a lab environment. And not only that, it's very well sealed. I mean, it's got this huge rubber gasket around the whole thing. Hopefully this doesn't just like destroy the adjustments dial. I don't know if I have to disassemble that to get to this. Now what exactly are these screws taking off? That's the question. Is it trying to take off the front panel? I think it is. Let me see if I can pop something in there. This feels... yeah. There we go. Okay, so here's the mechanism. Okay, it's just snapped right here. See, this plastic piece should be connected to this plastic piece so it travels smoothly. And see, look at the design of this thing. It's got this flexible piece of plastic right here designed to act like a spring and lock it in, right? Well, what is that doing? Every time you do that, it's putting all the stress on this piece, and obviously it broke one day. So I'm going to clean this off, and I'll just put like a drop of super glue and see if that'll just hold it. I don't have any like proper like plastic cement. But yeah, and there's also no, I don't see any electronic connection to this, so there's no electrical connection to the board, so it doesn't, it's not like the range switch is going to be locked or anything. I was able to go to all the different modes, so I'm going to see what I can do about this plastic piece. Hang on. Well, I give up. I've been trying to glue this for the last little while, and it's I'm using Loctite super glue, their ultra gel, which I think is easily the best super glue in the world. But it's very strange. I tried putting just a teeny tiny drop on, and it just refuses to set. This has been liquid for like 5-6 minutes now. I don't know. Maybe it's... I mean, I've been using this bottle for a while and no problems. So I don't know. Maybe it's some weird plastic that just doesn't... it prevents it from setting properly. But either way, I'm just gonna not put this in. No big deal. If I ever get some proper glue, I can put that on, and or like plastic cement, and put that back on. So in the meantime, I'm going to get this reassembled and we'll turn it on. I've had my trusty DMM Check Plus powered on for quite some time now, and we'll just do some basic measurements and see how far out this thing is. Got it back together without the little shutter, and everything seems to still power on. This thing does use soft power, which is a little odd. Okay, powered on. Let's hook this up to voltage. 5 volts. I think that is what it's calibrated to. Let me check my little trusty sheet. Yep, 5 volt DC reference, exactly 5 volts. Let me see. 5 volt. Interesting. I haven't really used this thing before. So let's try AC. And we have to do the little select thing. 5 volts. AC voltage is 4.999 according to this, so that's good enough for me. And we will try resistance. This should be 100K. Yep. 10K. Yep. Wow, this thing auto ranges very quickly on resistance. Cat's meowing again. 1K, spot on. And 100 ohms. Yep, I have it recorded as Oh, this one's a little high, actually. Mine is, on my sheet it says it's 99.995, so that's a little off. Just trying it on the amps range, and on microamps it's not dead on like the other ranges. See, if I hook it up to my 17B, see, that's much closer to the 1.0004 that it should be. So this range is a little off, and going up, see, these are a little below 1. So again, that's off just slightly. Just watching it settle on the AC mode, and it is, yeah, there we go. It's dropped out pretty much by the same amount on AC. So yeah, the current range is off by just a bit. It's just a tad low. Huh, it's a little high on this range, but I think that's, no, it's exactly one milliamp on AC. So it's a little high here. Little, oh, it's a little high on that one now too. Oh no, wait, hold on, sorry. I have to tell it AC. Ugh, hate that. Why the hell can't they have a proper AC spot on the switch? Yeah, see, it's a little low there. There you have it, the 973A. It's not a bad multimeter for the price I got it at. Actually, you know what? Let me do one more test. One of the main things I forgot to try was the diode test. Can it light up a blue LED? Yep. Can we light up a yellow one? I imagine so. Yep, dimly. And a white one. Let's see if the white one lights up. Anything? Hey, it can light up a white LED. Ooh, barely. And the other thing I wanted to check was the continuity mode. Let me use my lovely Probe Master probes for this one. Just because those little clip probes are so cheap. They're like 95 cents on eBay. Let's use some real probes for this. Alright, we'll try this continuity mode. Ooh. It's pretty slow. It's latching, but pretty slow. Let me try the, forgot what it's like on my Fluke 17B Plus. Way faster. Not perfect. I mean, it's definitely not instant. But it's definitely faster than on this guy. The slow continuity tester is pretty much the only bad thing I've found on this thing. I mean, you've got nice stuff like relative, min-max, range measurements, averaging. You've got, this actually has dBm for voltages. And it does have a lot of nice features. This dial is pretty crusty. It just doesn't feel nearly as nice as the one on this, even this cheap-ass Fluke. But other than that, this is a pretty good multimeter, especially for a 0.1% model that I got for 40 bucks. There is a 74 and there's a couple others. I think there's a 73, or sorry, a 72 and a 71. The 74 goes up to 4.5 digits, and it's a 50,000 count instead of just the, I think this is just 4,000 count, and 3.5 digits. But that being said, this one is pretty good. I'm not complaining about it. And It's certainly better than like the $10 one I have around here somewhere, and it's bad. I actually just won a multimeter for like $4.50. So we'll do a teardown of that in the future and see how good that one is.